Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, Power BI integration. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is Analyze in Excel, and how does it differ from importing data to Excel? Analyze in Excel is a feature in Power BI that allows users to connect an existing Power BI dataset directly to Excel and perform ad hoc analysis using pivot tables, charts, and slicers. Unlike importing data, Analyze in Excel does not create a static copy of the dataset. It queries the live Power BI dataset. Any updates or changes in Power BI are reflected automatically in Excel. This feature is particularly useful for users who prefer Excel's interface or want to leverage Excel functionalities like pivot tables or advanced formulas on top of Power BI datasets. It maintains security and permissions from Power BI, meaning users will only see data they have access to according to dataset rules. Second question: can you connect a Power BI dataset with row-level security, RLS, to Excel? How does RLS affect the data? Yes, you can connect a Power BI dataset with RLS to Excel, but the data visible in Excel will respect the roles and permissions defined in Power BI. Each user connecting via Excel will only see the subset of data they are allowed to view according to their RLS role. If a user without permissions tries to access data, they will either see limited data or may be denied access entirely. This ensures consistent security across platforms, whether accessing the dataset from Power BI or Excel. Third question: what are the limitations of Analyze in Excel in terms of dataset size or features? Large datasets may have performance issues because Excel sends queries back to Power BI each time a pivot table or slicer is refreshed. Certain Power BI features, such as calculated tables, hierarchies, or complex DAX measures, may not behave exactly as in Power BI visuals. Users cannot edit the dataset structure in Excel, they can only analyze it. Any changes to measures or relationships must be done in Power BI Excel versions prior to Office 2016 or older 32-bit editions may not fully support Analyze in Excel functionality. Fourth question: walk me through connecting a Power BI dataset to Excel and creating a pivot table. Open Power BI Service, navigate to the desired dataset, and click on Analyze in Excel. This downloads an ODC, Office Data Connection, file. Open the ODC file in Excel. It automatically connects to the Power BI dataset and shows a pivot table field list. Drag fields into rows, columns, and values areas of the pivot table to build your analysis. Use filters and slices to interactively explore the dataset, and any changes in Power BI will reflect when refreshing the pivot table. Fifth question: how would you troubleshoot if a measure or column doesn't appear in Excel after connecting to Power BI? Check whether the missing measure or column is hidden in the Power BI dataset, as hidden fields do not appear in Excel. Verify that the user has access to the dataset. RLS or permissions might restrict visibility. Ensure that Excel is using the correct connection file, ODC, and that the dataset in Power BI has been refreshed. Sometimes, older versions of Excel or missing updates prevent all fields from appearing, so ensure Excel is updated and supports Analyze in Excel. Sixth question. How can you use Excel slices on a Power BI dataset pivot table for interactive analysis? Insert a slicer in Excel by selecting the pivot table and clicking Insert then Slicer, then select the field you want to filter interactively. Connect the slicer to the pivot table to dynamically filter data, similar to how slices work in Power BI. You can use multiple slices together for multi-dimensional filtering. Each interaction with the slicer sends a query back to Power BI, so the pivot table always displays the most up-to-date data. Seventh question. Explain the difference between Publish to Web and Power BI Embedded. Publish to Web is a simple way to share Power BI reports publicly via a URL or embed code. Anyone with the link can view the report without authentication. Power BI Embedded is a paid service designed for developers to embed reports and dashboards securely into apps or websites, with user-level authentication and granular control. Publish to Web is intended for public or non-sensitive data, while Power BI Embedded is used for secure, enterprise-grade applications. Power BI Embedded allows for app-specific features like row-level security, API-based controls, and custom branding, which Publish to Web does not support. Eighth question. What are user-owns data versus app-owns data embedding scenarios? User-owns data. Each end-user authenticates with their own Power BI credentials. The report respects the user's permissions and RLS. This is ideal for internal apps or portals. App-owns data. The application authenticates with a service principal or master account, and end users do not need individual Power BI licenses. The app controls which reports each user sees. User-owns data ensures data visibility is tied directly to the user, while app-owns data is flexible for external clients or multi-tenant applications. App-owns data allows custom authentication and embedding workflows, often used for SaaS products or customer-facing portals. Ninth question. How does authentication and row-level security work in embedded reports? Authentication ensures only authorized users can access embedded reports. This can be done via Power BI service accounts, Azure AD, or service principals depending on the embedding scenario. In user-owns data, RLS is automatically applied based on the user's Power BI role. Users only see the subset of data they are allowed to view. In app-owns data, developers need to pass effective identity or username mapping when generating the embed token to enforce RLS for each end user. Proper implementation of authentication and RLS ensures data security and prevents unauthorized access even when reports are embedded externally. 10th question. What are the benefits of using Power BI Embedded Capacity? Provides dedicated compute resources, ensuring faster rendering and better performance for reports and dashboards. Allows embedding for external users without requiring individual Power BI Pro licenses, reducing licensing costs. Supports high scalability, making it suitable for apps with a large number of users or complex reports. Offers advanced control via APIs, such as report filtering, page navigation, exporting, and applying RLS programmatically. 11th question. How would you embed a Power BI report into a website using Publish to Web? Open the desired report in Power BI Service and click File, then Publish to Web. Copy the generated embed code or URL and paste it into the HTML of your website. Users visiting the website can view the report directly without signing in, as published to web bypasses authentication. Remember that this method exposes the report publicly, so it is not suitable for confidential or sensitive data. 12th question. In App Owns Data embedding, if a user cannot see the report, what could be the reasons? The embed token may have expired or was generated incorrectly, preventing access. The user may not be mapped correctly to an effective identity for RLS, so the report appears empty. The application service principal or master account might lack Power BI Pro license or sufficient permissions to access the dataset. Network or firewall restrictions could block API calls to Power BI service from the application. 13th question. How do you implement RLS for different users in an embedded report? Define roles and rules in the Power BI dataset using DAX filters to restrict data per role. In App Owns Data, generate an embed token that includes effective identities, passing the username and roles to enforce RLS for each user. For User Owns Data, RLS is automatically enforced based on the logged-in Power BI user. Test RLS by embedding the report and logging in as different users to ensure they only see data allowed for their role. 14th question. Why and when would you use Python or R in Power BI? Python and R are used in Power BI to perform advanced analytics, statistical analysis, and machine learning that are not available natively in Power BI. They are helpful when you need custom visualizations or want to leverage libraries like Matplotlib, Seaborn, Python, or ggplot2, dplyr, R. They allow data transformation or cleaning beyond what Power Query can do, such as detecting outliers, text processing, or predictive modeling. Useful for data science workflows where datasets require complex computations, modeling, or insights that standard visuals cannot provide. 15th question. What is the difference between using Python or R as a data source versus visual? As a data source, Python or R scripts transform or generate data before loading into Power BI. This is equivalent to using Power Query, but with advanced scripting capabilities. As a visual, Python or R scripts are used to create custom charts or plots based on the data already loaded in Power BI. The visual only exists in the report view. Data source scripts affect the dataset itself and can be refreshed, while visual scripts only affect report rendering and cannot be reused in other reports. Visual scripts require minimal interaction with the dataset and focus on presentation, whereas source scripts focus on data preparation and transformation. 16th question. What are the security and refresh considerations when using Python or R scripts in Power BI service? Scripts cannot execute arbitrary system commands in Power BI service, so ensure they only use supported libraries for security. Datasets using Python or R scripts require on-premises data gateway for scheduled refreshes because scripts run locally, not in the cloud. Some Python or R libraries may not be supported in service. Ensure only supported libraries are used for refresh. Large or complex scripts can impact refresh performance, so optimize code and avoid heavy computations where possible. 17th question. How would you create a Python visual in Power BI? Enable Python scripting in Power BI Desktop under File, then Options, then Python Scripting, and set the Python IDE path. Select Python Visual from the Visualizations pane, and drag the required fields into the Values section. Write the Python code to generate the visual, for example, using Matplotlib, pyplot, hist for a histogram or plt, scatter for a scatter plot. The visual will render dynamically based on the data in Power BI, and you can customize colors, labels, and axes as needed. 18th question. You need to detect outliers in a dataset using Python before visualization. How would you implement it? Use Python scripts as a data source to pre-process the dataset before loading into Power BI. Import libraries like Pandas and NumPy, and use statistical methods, example Z-score, IQR, to detect or remove outliers. Filter or flag the outliers in the Python script and return a clean dataset to Power BI. Once loaded, you can create standard Power BI visuals or Python R visuals on the clean data for analysis. 19th question. How can you schedule refreshes for datasets that rely on Python or R scripts in Power BI service? Publish the Power BI report to Power BI service. Install and configure an on-premises data gateway because Python or R scripts need local execution for refresh. Ensure the gateway is running and the dataset uses it for refresh. Schedule refreshes in the Power BI service under Settings, then Datasets, then Scheduled Refresh, and test the refresh to ensure Python or R scripts execute correctly. 20th question. How do you handle RLS when users want to analyze Power BI datasets in Excel? Row-level security, RLS, in Power BI is automatically enforced when a user connects to a dataset via Excel using Analyze in Excel. Each user only sees the data they are allowed to view. Ensure that roles and rules are correctly defined in the Power BI dataset so that Excel users get the filtered view based on their assigned roles. Users must have proper access to the Power BI dataset. Without access, they cannot connect or will see restricted data. It is recommended to test Excel connections with different user accounts to verify that RLS is working correctly and no sensitive data is exposed. 21st question. A developer wants to embed a Power BI report with Python visuals into a web app. How would you approach it? First, ensure the Python visual is fully functional in Power BI Desktop, using supported libraries like Matplotlib, Seaborn, or Pandas. Use App Owns Data Embedding to embed the report securely, generating an embed token for each user if RLS is needed. Host the report in Power BI Service and use Power BI JavaScript SDK or REST API to embed it in the web application. Test the interactive functionality to confirm that Python visuals render correctly for all users and that dynamic filtering and slices work as intended. 22nd question. Power BI dataset uses Python scripts, but refresh fails in the service. What could be the reasons and solutions? Python scripts require an on-premises data gateway for refresh. Absence or misconfiguration of the gateway can cause failures. Some Python libraries used in the script may not be supported in Power BI Service. Ensure only supported packages are installed. Scripts performing heavy computations or memory-intensive operations may fail during scheduled refresh. Optimize the code or simplify the data. Check the gateway logs and dataset refresh history in Power BI Service to identify errors and fix them accordingly. 23rd question. Compare performance and limitations of Python or R visuals versus Power Query transformations. Performance. Python or R visuals run in the report layer, so rendering depends on the client machine, dataset size, and complexity of scripts, which can slow report performance. Power Query transformations are applied during data load, so visuals render faster because the dataset is pre-processed. Refresh. Power Query transformations are fully supported in the service for scheduled refresh, whereas Python or R scripts require a gateway and can fail if scripts are complex or unsupported libraries are used. Limitations: Python or R visuals are limited in interactivity. Slices and filters work only within the Power BI visual context. Power Query transformations allow full dataset shaping and are reusable across multiple reports. Flexibility: Python or R scripts provide advanced analytics, statistical modeling, and custom visualizations not possible in Power Query. 24th question. How would you implement a fully interactive embedded dashboard that updates dynamically with dataset refreshes? Use Power BI Embedded, App Owns Data, to embed the dashboard in the web application. Generate an embed token for secure access. Ensure the dataset has scheduled refresh configured in Power BI Service, ideally via an on-premises data gateway if using on-prem data or Python or R scripts. Enable interactive features like slices, filters, bookmarks, and drill-through so that users can explore the data dynamically in the embedded dashboard. Use Power BI REST API or JavaScript SDK to programmatically refresh the embedded report if needed or to synchronize dashboard elements with user interactions. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.